Okay, so let's talk about rate of change. Rate of change is the same thing as slope, which another way to hear slope is going to be your change of y over your change of x. So these triangles are not just triangles, they represent change. So how much are you going to change by? Okay, so if you ever see those, that's what that means. Now, let's go to our slope-intercept equation. The m always is going to stand for or represent slope. Your b is always going to represent your y-intercept. Okay, so there's the first way that we're going to discuss is going to be through tables. So your change of y. How do you get from 9 to 1? Well, you're subtracting, first of all, and then 9 minus 1 is going to be 8. So this is going to be your change of y. So rate of change, what we're going to do is change of y, which we just said is negative 8. So now we're going to go to x, negative 7 to negative 2. You're getting less negative, so you're getting closer to 0. So that means you are adding. And then you're actually adding 5. So this is going to be your change of x. So again, change of y over change of x is 5. Now, when you put in the calculator, you always want your simplified version. So if you put negative 8 over 5, you're just going to get negative 8 over 5. And that's it. That would be your rate of change. Now, another way that you can see the answer written is m equals negative 8 over 5 because, again, m represents your slope. So let's go ahead and do the second one. 25,500 to 20,000. Well, we're getting smaller. Okay, we're decreasing 5,250. This is your change of y. So again, change of y, it's going to be negative 5,250. So now let's go to our x's. How do I get from 1.5 to 3.25? Well, first of all, I'm getting bigger. Now, a way that you can figure this out, if you're like, Ms. Huerta, I don't know, just do 3.25 minus 1.5. That's going to give you 1.75. That's a way to help you find what the difference is. So this is going to be your change of x, which is 1.75. Now, when you put this in the calculator, you're going to get negative 3,000. And again, remember, the other thing that you're going to see is m equals negative 3,000. So, on a graph, we need 2 perfect points. So, rise over run is the same thing as slope. That's another way you probably heard it, which is the same thing as rate of change, which is also the same thing as change of y over change of x. All the same thing. So, let's go to our first graph. Okay, so if I were to draw a car right here, my awesome little car, okay, if I were to do that and I were to push it, it would go down. So this is a big hint that this is going to be a negative slope because you're going downhill. So you always go from left to right. So my left point is going to be this one right here. So that's where I'm going to start. So I'm going to go down to get to my next point. And you're just going to count 1, 2, 3, 4, 5, 6. So you went down 6. And when I say we're going down to our next point, you're going down to get even like this. So you're going to stop there. So you went down 6. So that's a negative 6. And that was your change of y. So my change of y is negative 6. So now we're going to find our change of x because x, this is my x and this is my y. I always go up or down for y, and I always go left or right for x. So x, I'm going to go right 1, 2, 3, 4, 5, 6, 7, 8. So I went right 8, and the reason it's positive is because you're going closer to the positive number. So that's going to be a positive 8. This is going to be your change of x. So this is going to be 8. Now, again, we need the most simplified version. If you were to go and put the answer of negative 6 over 8 as your slope, you are going to get it wrong because that's not the most simplified. So when you put in your calculator, you get negative 3 over 4. So m is equal to negative 3 over 4, and that is your slope. And that's it. Notice here, I'm actually going to go ahead and highlight this. You always get a little triangle right here whenever you're finding your slope. It's always going to make some type of triangle. So again, whenever you're finding your slope, you're going to have a little triangle. Now, let's go ahead and go to the next one. Again, you need 2 perfect points. Well, this one right here is a decimal. That's not a perfect point. So I'm actually not going to use this. So sometimes they will give you a point that is unrealistic. So I'm not going to use it. 5 comma 2 is a good point. Okay. So when I say perfect point, that means it needs to cross these lines, your grid, perfectly. And if it does that, then that's a perfect point. It doesn't matter which point you use. You can use, and I'll actually do 2 different examples so that way you guys can see it. You can use your y-intercept, because this one is 0, 3. You can use that one. I would go down 1, right? So that's my change of y. So my change of y is I went negative 1. And then I'm going to go 1, 2, 3, 4, 5. I went right 5. And so that's positive. And then 5, when you put in the calculator, it's just negative 1 over 5. Now, Ms. Huerta, what happens if I don't use that point? That's fine. Another point that you can use, let me do a different color, is going to be here. You can use negative 5, comma 4. You're going to get the same answer. So I'm still going to try and get even with my original point, 5, 2. So I'm going to go down 1, 2. So I went down 2. That's my change of y. So my change of y is negative 2. And then I'm going to go right. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So my change of x is positive 10. So I'm going to put that down. Change of x, 10. Well, when I simplify this, that's going to give me negative 1 over 5, which is the exact same thing as when I use my y-intercept. It doesn't matter which point you use as long as it's another perfect point. Now, lastly, okay, what we're going to do is whenever we have 2 points, there are 2 different ways you can do this, okay? So the first way is you can graph the points and do exactly what we just did. So if I have negative 2, that puts me right here. So this is negative 2, comma negative 2. Then you have 4, 2, and that's right here. 4, 2. Okay? Now, if you were to connect this line, right? If you were connected, it would give you that, right? So what you're going to do is, that means it's a positive slope. So you always go left to right. So I'm going to go up this time. 1, 2, 3, 4. And now I'm even with my next point. So this time I went up 4. That is my change of y. So my change of y is 4. Now I'm going to go right. 1, 2, 3, 4, 5, 6. So now I went right 6, which is my change of x. Now, if you, again, do not tell me your answer is 4 over 6, because it's not. Okay, it has to be simplified. So your answer is going to be 2 over 3, and that is going to be your m. That is the first way you can do that. Totally fine. So your slope of the line would be m equals 2 over 3. Okay, so the other way is going to be using, let me go to our reference sheet, is going to be using slope of a line formula. So it would be using this one right here. y2 minus y1, x2 minus x1, because you're given 2 points. So here, I'm going to put m equals y2 minus y1, x2 minus x1. So what that means is let's go to the point. This is my negative 2 is my first point. x1, y1. Again, it's my first point. So then I'm going to go to my second point. This is x2, and this is y2, because that's my second point. All I'm going to do is substitute those numbers into that formula. So here, always put parentheses whenever you substitute. And those are minus signs. So my first one is y2. So y2 is going to go here, which is 2. y1, negative 2, is going to go right here. And then x2, which is 4, is going to go right here. And then lastly, x1 is going to go right here, which is negative 2. Now, just be careful how you put this in the calculator because, again, these are minus signs. The other ones are negative. So when you put in the calculator, you're going to get the exact same thing. You're going to get 2 over 3, which is what we got. It doesn't matter which method you use. As long as you pick one of them and stick to them pretty much every single time, then you're going to be just fine.